Imagine standing on the surface of the moon. No wind, no sound, no movement, just silence so complete it almost feels heavy, like something is pressing down on you. Above you, the sky is perfectly black, even in full daylight, and beneath your boots, the ground is covered in a fine gray dust that may have remained untouched for billions of years. At first glance, it looks calm, it looks peaceful, it looks safe. But that calm is one of the most dangerous illusions in the entire solar system, because the moon is not what we think it is. We grow up seeing it every night. It feels close, familiar, almost comforting. We've watched humans walk on it. We've seen the footage. We've seen the flags, the footprints, the slow motion jumps. 12 people went there, and they all came back. So it feels conquered. It feels understood. It feels safe, but it isn't. And the truth is, the astronauts who went there didn't stay long enough to discover what the moon actually does to you. They were visitors. They arrived, explored, and left before its dangers had time to fully reveal themselves. But over the decades since Apollo, we've started to understand something deeply unsettling. Going back to the moon is one thing. Staying there is something else entirely. And the first problem, the one that starts almost immediately, is something that sounds harmless at first. Dust, not massive craters, not radiation, not extreme temperatures, at least not yet. Dust. Every single Apollo crew reported the same issue. It got everywhere. It coated their suits. It clung to their gloves. It scratched their visors. It jammed their equipment. It invaded seals and mechanisms that were supposed to be airtight. And the more they tried to remove it, the worse it became. Brushing it off didn't work. It stuck harder. Shaking it didn't help. It lingered. And when they brought it inside the lunar module, it became something far more dangerous. In the moon's weak gravity, the dust didn't settle. It floated. It drifted through the cabin like smoke, suspended in the air, refusing to fall, and the astronauts breathed it in. Almost immediately, their bodies reacted. Apollo 17 astronaut Harrison Schmitt described what he called lunar hay fever. His eyes burned. His throat became irritated. His sinuses swelled shut. He started sneezing uncontrollably. Other astronauts reported similar symptoms: sore throats, watery eyes, congestion that lasted for days, and all of them noticed the same strange smell the moment the dust entered the cabin. Burnt gunpowder. That smell came from the dust reacting with oxygen and moisture for the first time. On the surface of the moon, there is no atmosphere. No oxygen, no humidity. The soil exists in a kind of chemical suspension, but the moment it enters a human environment, it changes, and that's when it becomes dangerous. Because lunar dust is not like dust on Earth. On Earth, particles are worn down over time by wind, water, and weather. Their edges become smooth. On the moon, none of that exists. For billions of years, micrometeorites have been smashing into the surface, grinding rock into an incredibly fine powder. But instead of being smooth, each particle is sharp, jagged, more like microscopic shards of glass than dust. The edges are so fine they can't even be seen with the naked eye. And when these particles come into contact with moisture, like the moisture inside your lungs, they don't just sit there. They react. They bond to surfaces. They cling to tissue. And unlike ordinary dust, which your body can often clear out, lunar dust can penetrate deep into the lungs. Some particles are so small, they travel deep into the respiratory system and stay there. And in the moon's low gravity, they remain suspended in the air longer, which increases the chances of inhaling them. This isn't just uncomfortable, it could become a long-term health risk. Apollo astronauts were only exposed for a few days. Future missions will last weeks. A permanent base would mean constant exposure. And the truth is, we still don't fully understand what that would do to the human body. And beyond the physical danger, there is something else that rarely gets talked about. What it feels like to live there for days, then weeks, then months. No air, no weather, no sound, no natural movement of any kind. No wind against your skin. No rustling leaves. No distant noise of life. Just silence. And not the peaceful kind. The kind that reminds you constantly that you are somewhere you were never meant to survive. Every breath you take is artificial. Every step you make depends on technology that cannot fail. Every second outside is a controlled risk. And psychologically, that matters. Humans evolved in environments full of sound, motion, and life. On the moon, there is none of that. And over time, that isolation could become as dangerous as any physical threat. But the dust doesn't just sit there quietly. It does something even stranger. Under intense solar radiation, the surface of the moon becomes electrically charged. Ultraviolet light from the sun knocks electrons off the ground, creating a positive charge, and the smallest dust particles pick up that charge and lift off the surface. They hover. They drift. They move in ways that almost resemble a kind of invisible storm. Some models suggest these particles can rise meters, even kilometers above the surface, forming a thin cloud of floating glass around the moon. On the dark side, the process reverses. The surface becomes negatively charged, and at the boundary between light and shadow, electric fields may push dust sideways across the terrain. In other words, the moon isn't just covered in dangerous dust. That dust is active. It moves, it sticks, it floats, it infiltrates everything, and there is currently no perfect way to control it, contain it, or fully remove it from equipment or living spaces. Now add radiation. On Earth, we are protected by two powerful shields, our atmosphere and our magnetic field. Together, they block or deflect most of the radiation that would otherwise reach us. On the moon, those shields don't exist. There is no atmosphere. There is no magnetic field. That means astronauts on the lunar surface are exposed to the full force of space radiation. This includes galactic cosmic rays, high-energy particles that have traveled across the universe at nearly the speed of light. They pass through spacecraft. They pass through walls. They pass through human tissue. And as they do, they damage cells, they break DNA, and they increase the risk of long-term health effects, including cancer. But here's where it becomes even more complicated. Shielding against this kind of radiation is incredibly difficult. Adding thicker walls doesn't always help. When these high-energy particles strike dense materials, they can produce secondary radiation, creating a cascade of additional particles inside the structure. That means the very thing designed to protect you can sometimes make the problem worse. And on top of that constant background radiation, there are solar particle events. These are sudden eruptions from the sun that can flood space with high-energy particles in a matter of hours. On the International Space Station, astronauts are still partially protected by Earth's magnetic field. On the moon, there is no protection. A large solar event could expose astronauts to dangerous or even lethal levels of radiation in less than a day. The Apollo missions were fortunate. They occurred during relatively quiet periods of solar activity. But a similar mission during a major solar storm could have ended very differently. And even if you solve the dust, and even if you solve the radiation, the moon still has another challenge: temperature. A single lunar day lasts about 14 Earth days. During that time, the surface heats up to around 127 degrees Celsius. Then comes the lunar night, another 14 days, when temperatures drop to roughly minus 173 degrees. That's a swing of about 300 degrees. With no atmosphere to regulate it, no wind, no weather, no buffer of any kind, just extreme heat, followed by extreme cold again and again. This kind of thermal cycling is incredibly destructive. Materials expand and contract, seals crack, metals weaken, electronics fail. The Apollo missions only had to survive these conditions for a few days, but a long-term base would need to endure this cycle repeatedly for years. Every component, every joint, every system would be under constant stress. And then there's something even more unexpected. The moon isn't completely stable. It's shrinking. As its interior cools, the entire body contracts. But the crust can't shrink smoothly, so it cracks, it fractures, it forms cliffs and fault lines across the surface, and those fractures can produce moonquakes. Not ancient ones, recent ones, active ones. Well, some of these quakes originate close to the surface and can be surprisingly strong. But what makes them particularly strange is how they behave. On Earth, earthquakes come and go quickly. The ground shakes, and then it stops. On the moon, the vibrations can last much longer. The energy doesn't dissipate in the same way. Instead, the ground can keep ringing for hours, like a bell that has been struck. And that prolonged shaking can destabilize the surface. It can trigger landslides. It can send loose material sliding down crater walls. And those crater regions are exactly where we hope to find water ice, one of the most valuable resources for future missions. So the areas we want to explore the most may also be among the most unstable. And finally, there are the impacts. On Earth, most small meteoroids burn up in the atmosphere before they reach the ground. On the moon, there is nothing to stop them. Tiny particles slam directly into the surface at incredible speeds, up to tens of thousands of kilometers per hour. Over billions of years, these impacts are what created the lunar dust in the first place. But they're still happening. For a space suit or a habitat, the danger isn't a single impact. It's the accumulation over time, the constant sandblasting effect of high-speed particles gradually wearing materials down. The Apollo astronauts saw this firsthand. In just a few days, their suits showed visible signs of wear. Future systems designed to last months or years would face far greater exposure. And when you take all of this together, the image of the moon changes completely. It's no longer a quiet, silent world. It becomes something far more hostile, a place where the ground itself can harm you, a place where invisible radiation passes through your body, a place where temperatures swing between extremes, a place that is slowly cracking from within, and a place constantly bombarded by space itself. We've been there before, but only briefly. We were visitors. We arrived, we explored, and we left before most of these dangers had time to fully reveal themselves. But the next time we go, we may not be leaving so quickly, and that changes everything. Because going to the moon is an achievement. Staying there is a challenge. Surviving there is something else entirely. And the moon, silent as ever, will still be waiting, not as a gentle neighbor, but as a world that has spent billions of years becoming one of the most unforgiving environments we've ever tried to explore. If you found this journey into the hidden dangers of the moon fascinating, make sure to like the video and subscribe for more deep space discoveries. Because the universe isn't just beautiful, it's far more hostile than we ever imagined, and we're only just beginning to understand it.